out of boundary path. For this question, we're given a grade and we have a ball uh, uh, which pointing to a cell of the grade, and it is asking how many moves, right? It gives the maximum move, and how many moves can we move the ball to out of the boundary, right? Okay, so for this example, for the first one, we see a 2 by 2 cell, and we have the ball at the right left top corner, and then if we have only one move, we have two different moves to be able to move it out of bound, right? So on the other hand, if we have two moves, we can move twice. Then we have four different ways of moving out of bounds, right? So if the input is maximum of two, then we are going to sum all the moves with one, all the moves with two together. So we're going to return six at the end, right? So second example, similarly, we have a 1 by 3 cell, and then the ball is in the middle. So after we have calculated move 1, move 2, and move 3 times, and we sum them up together, we can return 12 at the end. Okay. So for this question, let's take a look at the what is the intuition behind it. So for this example, it turns out that we can calculate the move n based on the move n minus 1. So how do we do that? So for move 1, we know that the left top corner will be 2. Similarly, for every single cell will all be 2, two ways of moving the ball out of bound, right? And then for move 2, on the other hand, like how do we calculate each of the cells? So for example, we're still taking the left top corner cell as an example. So this one, we can move to the right, and we can also move to down, right? Because like we wanted to move the ball out of bounds at exactly two moves, right? So because we calculated one move already, so this is the exact move. We cannot move the ball out of bound at the first move. We're gonna move it to some valid location, and then we're gonna move it out of bound. So that's for move 2, right? So we can move right, and then we can move down. So when we move right, we have one move left. We're gonna consult to the move 1 table, which we see, oh, there's a 2. There are two ways of moving out of bound, right? And then similarly, when we move down, there's one move left. We're gonna consult previous move table, which is move 1, and there are two ways. So 2 plus 2 is 4. So this cell has total move of 4 different ways we can move out of bound and use exactly 2 moves, right? So similarly, if we take another example for like similar to example 2, right? So which is move 1, we have 3, 2, 3. We can quickly verify that this cell has 3 different moves, up, left, and then down. So meaning that one move, we're going to move it out of bounds, right? 3 different ways. And then center cell will have 2, and then right cell will have 3. So this is we know we initialize this. For move 2, very similar way. How do we calculate this? We're going to see where can it move to. So for this cell, we can move it right only. So that's the only place it is a valid move. So we're going to move to right, and then we have one move left, which is we're going to go here and then see, oh, so there are 2 ways if there is one move. So that's why we put 2 in here, right? Similarly, for the rightmost cell is 2. So how about the middle? So in here, we can move either left or right. So both places we have 3, and 3 plus 3 will be 6, so we have 6 in here. And so on and so forth. We can have move 3. Similarly, we're going to consult to move 2, right? And then we get the move 3 grade calculated. And then finally, we can plus all the cells corresponding to the boss location. So if it's in the middle, then 2 plus 6 plus 4 will end up with 12. Okay, so this is our intuition on how to solve the problem. Like by maintaining a previous grade, we can calculate the current grade. And then we keep going, we keep iterating through the moves until we reach the maximum move. And we plus all the corresponding cells of the ball together along the way. So that will give us the final result. Let's take a look at the code. All right, so first of all, if the maximum is 0, we're going to return 0 directly because there's no way of moving out of bound. And we maintain a previous grade, and we have a current grade. So based off of the previous grade, we're gonna populate the current grade. How do we do that? So first, at the beginning, we're gonna calculate the initial state of the grade, right? So initialize the previous grade in this case. Iterating through each of the grade and the initial moves with the four directions, because that's where we can move the ball, right? So for I and j, we're gonna initialize with I minus, like moving left, moving right, moving up, and moving down, right? So this is where we initialize the previous ij. So what is the initial move? So initial init move is if the grid, like the position, is valid, then we return 1. Otherwise, we return, if the position is invalid, then we return 1. Otherwise, we return 0. What does it mean? So if the position is invalid, meaning it's out of bound, right? Then we see, oh, okay, this is a valid move because at move 1, we can move it out of bounds. And otherwise, we return 0. There's no way to move it out of bounds, right? So the previous array, like to the grade in this case, is denotes the moves for move 1, right? So after that, we have the previous grade, and then we're starting from the move 2, move equals 2, until the maximum move. We keep going, and we initialize the current grade for every single time, and then based on the previous grade, we're going to calculate what is the current grade. Okay, so how do we do that? So we have a get move in here. So what we are doing is for get move is we are going to calculate whether it is out of bound or not. So if it's out of bound, then we return 0 because that's not valid. Remember, this time we are trying to figure out what is valid moves, right? So which is not out of bound, and then if it's valid, then we're going to return previously, like we calculated the moves from previous grade, right? So and then for each of the up, down, left, and right, we calculate them. So this is just making sure that it's not too big of a number, so that it doesn't fit the integer. So this is required by the description itself. So after all of these, we added each of the moves for up, down, left, and right if they're valid to the current grade, and then we have the current grade, and then we're gonna augment the final result with starting row and starting column, which is the position of the ball, right? And then finally, we are going to override the previous with the current, and we keep going until we reach the maximum move.